Hello, everyone. Today we're going to be discussing how infrared spectroscopy works, and how it works to identify functional groups present in organic compounds. Now, infrared light is just another part of the electromagnetic spectrum. Here we see the full spectrum. Gamma rays have the highest energy with a high frequency and a small or short wavelength. Radio waves have the lowest frequency or energy and a long wavelength. We are interested in today's lesson in infrared rays, which have a slightly lower energy than the visible light spectrum. Now, in a laboratory, what you can do is you can place your sample in one of these pieces of equipment called the Fourier transform spectrometers. And what the machine does is emit infrared light through the sample. So some wavelengths of light are absorbed and others are not. And that depends on the bonds present in your molecule. Okay, now what wavelengths are absorbed depends what bonds you have. In organic chemistry, you may have a single bond between two carbons or maybe a double bond between carbons. When the light goes through the compound, if it is absorbed, it causes this bond to vibrate, and that's where the energy is going. If this energy is absorbed, the bond vibrates in different ways. Depending on the bond, you will absorb a different wavelength of energy. Now, let's have a look at, once the machine is done, what can we expect to see? Now, this is the infrared spectrum of ethanol. Okay, now on the y-axis, we have something called transmission or transmittance. If the infrared light at a specific wave number, let's say 4000, goes through the sample and nothing is absorbed, it will be close to the 100 mark. However, if the sample absorbs around, let's say, 3200, as we can see here, we will see a dip or a peak. That's because that energy is not going through and it's not getting detected at the end, because instead it's being absorbed by the compound. We see another peak here, around 3000, and some peaks below 1500. Now, this is the basics of how infrared spectroscopy works. On the x-axis, you can see a value wave number. Now, this is the same thing as the reciprocal of wavelength, 1 divided by lambda or wavelength. Okay, in the IB, you get this data table, and it tells you where you can expect to see different bonds, at what wave number and what intensity. Okay, in the second part of this video, I'm going to be going through different functional groups, different compounds, and what the spectrum would look like.